Matplotlib is one of the most important plotting libraries in Python in the modern days. There are many plotting tools, but matplotlib.pyplot is one of the most useful tools. And this plotting library itself, the whole plotting module itself, is inspired by plotting tools that were available in MATLAB. And the reason for this might surprise you that a lot of machine learning and data science and AI scientists actually come from other areas like physics, like astronomy, um, like applied mathematics and statistics, like applied math and statistics. And also a lot of engineers from electronics, all these areas. Of course, there are, of course, CS folks out there. But many of these people in sciences and in electrical engineering and applied math are used to MATLAB. MATLAB is one of the most popular scientific computing toolboxes out there, especially for scientific computing. So when people started building a Python specific plotting library for machine learning, data science, and AI, they said, okay, we are all used to MATLAB syntax. We all are very used to how to plot things in MATLAB. So why don't we build a plotting library just like the one that we're used to in MATLAB? And that's the inspiration for matplotlib.pyplot. Okay, so having known this, now let's go and look at some very simple examples. I'll explain you some basics of plotting. For more details about plotting, we have a chapter called exploratory data analysis where we look at multiple types of plots. And in exploratory data analysis, in addition to pyplot, we also use another library called cborn, which has extremely beautiful and nice plotting tools. We will learn about cborn in the exploratory data analysis chapter. Okay, now let's import it. Okay, so you can import matplotlib.pyplot as plt. So this is the alias that I'm using because I don't want to keep typing matplotlib.pyplot every time. Now let's look at it. Suppose if I want to plot these values. Okay, so what I have here is these are my y values, right? 2, 4, 6, and 4, right? And if you look at this plot here itself, if you look at this plot here, what were my numbers? 2, 4, 6, and let me just look it up. Okay, 6 and 4, right? So these are the y values, right? These are the y values. There were no x values specifically mentioned for my plot. If the x values are not mentioned, then the indices like 0, 1, 2, 3 become my x-axis. Because when I'm plotting, I didn't mention anything about my x-axis, right? So if no x-axis values are given, your indices, because this was at index 0 in the array, this was at index 1, this is at index 2, and index 3, the same value. So if you notice here, at 0, you have value 2. At 1, you have value of 3, roughly here. Oh, sorry, 1 you have value of 4, sorry, my mistake. At 2, you have a value of 6, and at 3, again, you have a value of 4. Now, these 4 dots are connected now. So, your pyplotlib, your matplotlib, sorry, not pyplotlib. Your matplotlib, if you just say plt.plot, and I just gave a list, right? I just gave one list. So it will plot these list elements as elements of the y-axis with the indices, this being at 0th index, first index, second index, third index as the corresponding x-axis. Now in this code, one thing you'll notice is I have set something called y label as numbers, x label as indices, and title as my plot, and I've set plot.show. These are the 4 lines of code that I have. Now let me explain each of these pieces. When I say plot.title my plot, what you see here is called the title of the plot. Okay, what you see here is called the y-axis label or the y label, because this is the y-axis, right? So if you look at this plot, this is the x-axis and this is the y-axis, right? And we had these 4 points and we had these 4 points, right? So your x-axis points were indices, so 0, 1, 2, 3. Your y-axis points were 2, 4, 6, and 4. Exactly those points. And we said the title, this is called the title, and this is called the x-axis label, and this is called the y-axis label. For a given plot, these 3 things are important. This says what the plot is all about. This says what is the x-axis. Here I've said indices, right? Because those are the indices or the indexes of each of these elements. And hence I call it indices. And the y-axis is the number that I'm plotting. Now, to do that, it's very, very simple. You just have to say x label and y label. If you say plot.x label, it sets that as x label. If you say y label as numbers, it sets that as numbers and title, right? So there is one problem with this plot, if you have noticed. One problem with this plot is that I don't see a grid See, one of the other useful things in a plot is a grid-like structure like this, right? A grid helps you read these values much more easily. That grid is not present. We'll see future code where we'll see how to get that grid, right? Now look at this. Now in this case, instead of giving one array of numbers, I've given two lists. When I give two lists, this becomes my x-axis and this becomes my y-axis values. One thing you'll quickly notice is if my x-axis is 1, my y-axis is 1. If my x-axis is 2, its corresponding value is 4, and 4 is nothing but 2 squared. Similarly, 3 squared is 9, 4 squared is 16. And what is my x label? My x label is numbers, my y label is squares. I have not set a title here. But here there is one interesting line here. Here I am saying plot.grid. The moment you say plot.grid, you get this grid. This is what I mean by a grid, right? So let's go down and see this plot, right? For 1, you get a value of 1. For 2, you get a value of 4. For 3, you get a value of 9. For 4, you get a value of 16. And you can much more easily read these numbers because of this grid that you have here. This is called the grid, right? This is called the grid. And how do you set the grid to be visible? For example, in the previous plot, we did not have the grid. And you can just set the grid by saying plt.grid, right? So then the grid is visible. And you know how to set the x label and the y label. I haven't set a title here, but you can set it if you choose to. So those are very, very simple commands which will help you plot. Oh, again, here remember, instead of giving one list here, I've given two lists. Hence, this becomes my x-axis values and this becomes my corresponding y-axis values. Now let's go down a little. Now instead of a line plot, if I want to get a slightly different plot, right? Let's look at this plot here. Here what I'm saying here is plt.plot. These are my x-axis values. These are my y-axis values. Again, squares of each of them. But here I'm saying RO. So what RO means is R here means the color of each of these dots is red. That's what the R here means. And O basically means that put dots here, put like O-shaped dots here instead of connecting them with a line. That's what it means. We'll see more examples as we go forward. Here also I'm setting the grid to be present and I'm saying plot.show. I don't have any X label, Y label or title here, right? Now let's go down and look at slightly more interesting things, right? So here, look at this plot. Here, what am I saying? First, on the same plot, if I want multiple things to be plotted, right? So let's go and look at this code first and then we'll go to the plot. So here I'm saying that T is basically a NumPy array with values between 0 and 5 and with intervals of 0.2, right? That's what I'm creating, right? So I have values like 0, 0.2, 0.4, so on and so forth up to 4.8, right? Now comes the interesting part. Now what we see here is I'm saying plt.plot T and T square. And here I'm saying that I want B. I want what B hyphen basically means is I basically want blue dotted line, or I should say dashed line. Sorry, it's not called dotted line. It's called a dashed line. Similarly, I'm plotting T and T power 2.2 here. Star basically means exponent, right? So each element in T, I'm exponenting with 2.2. Here I want red and S stands for squares. Okay. And I'm also giving a label here. I'm saying this line is square power 2. This is just any string you can give. The label for this plot is power 2.2. Similarly, I'm plotting T versus T power 2.5. And I'm saying green. And when I say a cap, when I say this, what it means is triangle. That's what it means. That means a triangle. And this symbol is literally above if you look at your keyboard, on top of 6, you have this sign. Right? It's often called as a caps lock, or it's also called the exponent key. Right? It's right above the key 6 on most laptops and desktops, on most keyboards. Here also I'm giving a label saying this plot corresponds to exponent 2.5. And I'm saying grid. And here there is another interesting line called legend. I'll explain you what legend is. And I'm saying show. Now let's go down to the plot. As you have seen, this is what is called a legend in a plot. This is called a legend in a plot. A legend, when you have especially multiple lines, a legend explains you understand. It helps you understand which line corresponds to what. And in legend, in Python, legends are filled with, so here I've given a power 2, power 2.2, power 2.5. Those are nothing but the values that I have in the labels. The values that I have in the labels come up in the legend. So you can give any value here, and that same values will come up in the legend here. Legends make it extremely readable. Legends make a plot extremely readable. Now, by looking at this, I know that, okay, this blue line is basically power 2, this red line is power 2.2, this green is power 2.5. And as you know, if you go back and see, the blue dashed line is squared, the red squares, and the green triangles. Right? So you can plot multiple lines in the same plot by just repeating plt.plot. And when you have multiple lines, it's extremely important to have a legend. Otherwise, you don't know what is what. You'll simply be lost. Right? Having learned this, now let's go a little more. Let's understand some more properties. Suppose if I want the line width to be more, right? Here I can say plt.plot x comma y. I have my x and y lists here, which I'm using here, and I have a parameter called line width. And if I give a line width of very large value, I get a line here which is very wide, right? And I'm just saying plot.show. There are many other parameters that you can look up in the documentation for this function. In matplotlib.pyplot, for the plot function, there are many parameters that you can use. One such parameter I'm just showing you here is called line width. Now, there is another very interesting thing called set properties. So let me explain you what it is. Okay, imagine I have x1, y1 as squares, x2, y2 as twice of these numbers. So these are 4 sets of lists that I have. Right? In a single line, you can plot both these lines. Right? You can say plt.plot x1, y1 and x2, y2. So now what it does is it plots x1 versus y1. So this is your x-axis and y-axis. It plots x1 versus y1. It also plots x2 versus y2. Now the fun part is this. What plt.plot returns is basically another variable called lines. And here it's plotting 2 lines, right? So I have actually lines 0 and lines 1. And now I can change the properties of these lines as follows. Let's look it up. So I can say plt.set properties for line 0. I can say I want the color to be R. What is line 0? Line 0 corresponds to the line between x1 and y1. Okay, this is line 0 and this will be line 1. And I want the line width to be 2. This is one way of writing it. This is using the keyword arguments, right? There is also MATLAB style arguments, which is I can say plt.set properties for line 1. If I'd say color and G, one after the other, what this is equivalent to, these two pair of commands are equivalent to color equals to G. That's what it means. And this is equivalent to exactly this. So this is how we actually use command line arguments in MATLAB. Since, as I told you, Matplotlib is very inspired from MATLAB, we can simply take this is the syntax. This is the MATLAB syntax, right? You can do this way or this way. If you're more of a original Python guy, you might want to prefer this because this is very native to how we think in Python, right? These are your keyword arguments. If you come from other branches where you've used Python, where you've used MATLAB extensively, you might find you might find this more similar to what you've used in the past, right? But in both these cases, see, I've changed my first line to color red, my second line to color green, and that's what you see here, right? So you have both these 2 lines and you see the colors having changed. Now, what if I want multiple plots? Okay, so we've seen how to play with one plot. Now here is an interesting part. So look at it like this, right? I have 2 plots here. I have t1, t2, and I have a function f, which uses some exponent followed by cosine and things like that. Okay, let's not worry what it does internally. I have a function. Now when I say plot.figure1, it creates a figure for me. In this figure, so it literally creates a figure for you, right? In this figure, I can create subplots. Okay, so when I say plt.subplot211, what it means is I want 2 subplots. What this means is I want 2 rows and 1 column. So what it's saying here is I want subplots with 2 rows, row 0 and row 1, and 1 column. Okay, it's breaking up this whole figure into sub-blocks. And it's saying this is the number of rows, right? This is the number of columns, and this is the figure number. And what is the first figure? First figure is here, right? This is the first figure and this is the second figure. Right? It's saying plot.subplot, 2 rows, 1 column, and the first figure is what I want. And the first subplot is what I want to plot. In the first subplot, I'm saying plot.grid and plot.plot t1 f t1 with a blue dashed line. Right? With a blue single line. If I put double dash, it becomes a dashed line. a blue colored line. So what happens is I'll get a plot here, I'll get some plot here, I'll get some plot here. Now I say plt.subplot 212, which means 2 rows, 1 column and figure 2, which means it is this part, right? 2 rows, 1 column and figure 2. Here it's plotting some other plot, right? Here it's plotting something else. Now I'm saying plot.show. So let's see the output of this. The output of this is basically 2 plots where the first plot is this. Where the first plot is the output of this. Second plot, this is the output. This is how in a single figure, you can break a figure. You can break a single figure into parts. So this is your whole big figure, which we have broken up into 2 parts. This is row 0, row 1, column 1. This is your figure 1 and this is your figure 2. Right? This is how we broke it up. If you have to plot multiple figures, there will be cases where you want to plot 4 figures, 1 figure here, 1 figure here, 1 figure here, 1 figure here. All of that is possible using the plt.figure and plt.subplot. We'll see slightly one more interesting complicated case here. Okay, so let's look at this. So here I'm saying figure 1. So it creates space for figure 1. Right? In this I'm saying plots 2, 1, 1, which means it's now broken this up into 2 subplots. Because it has 2 rows, 1 column, and in the first, this is the first figure, this is the second figure, right? In the first figure, I'm saying 1, 2, 3, plot 1, 2, 3. So I get a plot like this. In the second plot, I'm saying plot 4, 5, 6. I get one more plot here. Now here I'm saying plot figure 2, right? So figure 1 is over. Now it creates one more figure right below this. And in this, I'm saying plt.plot 4, 5, 6. So it just plots one value here. Because I have not created subplots here. In figure 2, I have not created subplots. This is my figure 1. This is my figure 2. Right? Now, after plotting figure 2, if I want to go back to figure 1, and in figure 1, if I want to go to this subplot and do something with it, how do I do it? I just now say figure 1. As soon as I say figure 1, I go back here. In figure 1, which subplot do I want to play with? I want to play with the 2 rows, 1 column, the first plot, which means this is this 2 rows, first column, and this is the first subplot. For this subplot, now I want to say plot.title. Suppose if I want to write some title here, I can just say easy as 1, 2, 3 as my title and just show. Now this is what should happen. You understood the flow, I hope, right? Now let's see the output of this. Exactly what we expect. This is your figure 1. Figure 1 has 2 subfigures, 2 rows and 1 column. My first figure I have easy as 1, 2, 3, which I changed at the end, right? And when I go down, I have my second plot here. What I would recommend you is play with this. Change, add one more figure. Play with this. Change these subplots. Play with all these changes so that you understand how to create multiple figures or multiple plots using this simple command. All you have to remember is the figure command and the subplot. And you can go from, you could have a complex structure where you have 2 figures here, right? And you have a big figure here, and you have 2 more figures here. That's very possible, right? So this thing could be figure 3, this thing could be figure 2, this thing could be figure 1. And at any time, you can go to any plot and change some property of the plot, right? So for example, you can go here and change. So I would like you to play. So the example that I have written here is the simplest of all. So there will be cases where you have to make plots like this. And I recommend you play around with this and understand how to create different types of plots. And Matplotlib is extensively used in machine learning and data science. As you will see in a lot of our work, I recommend you check out exploratory data analysis chapter, where we use, in addition to Matplotlib, we also use Seaborn a lot for various types of plotting.